This video demonstrates a Creed Morse printer in operation. It was designed in 1925 to read punched paper tape of Morse code signals and print the corresponding alphanumeric characters on another reel of tape. This printed tape was then cut into sections and glued onto the telegram form delivered to the recipient. The machine has a footprint about 9 inches square and weighs nearly 35 pounds, the frame being of cast and machined brass painted black. The high bit at the back is the reading unit. The slide on its right is where the punch tape feeds in. The rack and pinion on the left advances the tape by the length of the letter just printed. Bottom right, there's a tray for spools of typewriter ribbon for the print mechanism. Yes, that's a drill bit sticking out the bottom, improvised replacement for a missing pin. The shaft sticking out left is normally driven by an electric motor which is missing. The ID plate identifies it as a Creed Model I/T. It's what we'd call a daisy wheel printer, with the characters at the rim of this wheel that turns to place the selected character at the top to be hit by the hammer behind. Often this technology is said to have originated with the Diablo printer in the 1970s. In reality, the daisy wheel system was first used in 1889 on a primitive typewriter, which must have inspired this 1925 Creed technology. Getting the machine to work was a challenge because I haven't found any documentation on it except this diagram of the print wheel, useful because it has a list of the Morse code sequences corresponding to special symbols on the print wheel. Here's a picture of a working machine from the BT archive. The machine on the right is a perforator receiving Morse code from a telegraph line and recording it on the punched paper tape which feeds into the printer on the left. The printer is on a base which has a drawer for printer tape and an electric motor. The tape to be printed comes out of the drawer and after printing passes over a gum dispenser. Out of the picture on the left is an operator who cuts up the gummed printed tape and sticks it on a telegram form. The big puzzle is, why hasn't this machine got a typewriter ribbon attachment like mine? Where does it get its ink from? Let's see the machine running. I've borrowed this tape tray from another machine to keep the printing tape in tension. There's a short Morse message tape in the reader. I've attached a power drill to the drive shaft. There is a soundtrack online without video of one of these machines from which I estimate that it prints about 180 characters a minute. I'm running at less than half speed to reduce wear and tear. Here's a still of the Morse tape passing through the reader. It's a two-hole tape using the Wheatstone code. A dot is two holes in the same column, and a dash is a hole in the top of the first column and another in the bottom of the second. So you can see dot, space, dot, dash, dot, dot, space. That is E followed by L. When the first non-empty column arrives at the left of the reader, the holes between it and the next empty column count as a single letter. Having sent this to the printer, it then skips the tape over it and its trailing empty column. This is 12mm tape, which is now unobtainable. Here's the same tape running through. You can see the pins probing for holes. You can also see the rotating steel camshaft, which is the machine's brain, with eccentrics and grooves to make the various mechanical components cycle in 3 dimensions. You can also see the ink ribbon moving up and down to optimize ink use. The reader tells the printer where it found a hole by pivoting one of 20 steel bars that also move back and forth. At the other end, the bar drops when a hole is found, pushing a hidden lever that goes into that drum behind the print wheel. When the mechanism in the drum has turned the print wheel to the right place, all the bars go up and a series of 20 spring pins pushes the levers back to the no-hole position. You can see these spring pins mimicking the movement of the tape from right to left. From the rustic appearance of the 2 pins on the right, you'll guess that I made them. Here's what the levers look like when the letter S is detected. That's dot, 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 so the first 6 levers are all pushed back. Then a T, which is a single dash. Then an O, which is dash, dash, dash. This is what the spring pins look like after 95 years. The ones on the right are in worse shape because they work hardest. The 2 on the extreme right are broken. I made replacements using fine brass tube and steel piano wire and put them in at the other end where they have an easier life. The others I bent back into shape. And here's the bottom line. The printer wakes up after its long sleep. Thanks for watching. If you found it interesting, click the thumbs up button. If you'd like to see more in this series, click the red subscribe button. Hope to see you again.